2, go.
Hello everyone, welcome to another Weather Wednesday. How are you guys doing today? Welcome to the first few days of fall. Today we're going to talk about what causes the seasons and do other planets experience seasons as well. We're going to use Science on a Sphere here to answer those questions. So let me bring up one of my favorite images, Earth in true color. This comes from the GOES 16 and 17 images here. You can see the Western Hemisphere here, the United States, South America down here. And as we progress through here, you can see this bright reflection as it travels across the ocean. That is the sun as it reflects directly off of the ocean. Now you'll notice that the satellites can see the entire half of the Earth. This is because they are positioned at what's called a geostationary or geosynchronous orbit, where they can see half of the Earth, and they are positioned directly over the equator of our rotating planet. So as we take a look at this one right here, September 21st, September 21st is the official first day of fall, and that is the location. This is the location for where exactly the sun is exactly over the equator. So this bright reflection right here, this is where the sun is during the fall equinox, where the sun is directly over the equator. The sun will continue to travel south, giving the southern hemisphere its spring and summer, and the northern hemisphere will be experiencing our fall and winter. So there we see that bright reflection. Let's see where it crosses the South America right here. You can see a little bit. Let me see if I have my laser pointer right here. You can see a little bit of a reflection right here, and then you'll see it cross over. See that reflection right there on the east side of South America, and then cross over to here, where that is the exact equator on the Earth. Now, let's take a look at some pictures that I have prepared for our discussion of seasons here. Here is a beautiful image of some trees throughout the different seasons. I don't know about you. Are you experiencing some fall colors right now? Are your trees changing? Here in Colorado, we have some really beautiful yellows coming up on both the aspen and maple and oaks, and so lots of beautiful fall colors. Now, what causes those seasons? Why does the sun move on the Earth? Well, the answer is it's not the sun. It has everything to do with the Earth's axial tilt. You see, as the Earth rotates, it is tilted on its axis. In fact, it is tilted at about a 23.5 degree tilt. So if you guys are following along at home and want to do that as well, bend your body so that the top part of your head is angled just a little bit. And as you are angled, the Earth is rotating. When the Earth gets around the sun, some parts of the Earth is experiencing the direct rays from the sun, and that is when those direct rays hit the northern hemisphere, that is our spring and summer. And when the direct rays hit the southern hemisphere, that is our winter season and the southern hemisphere's summer season. So because the Earth is tilted, that's why we experience seasons. So then, if we look at the other planets, what we're looking for is seeing whether those planets are tilted. So starting with Mercury, is Mercury tilted? No, it is pretty much straight up and down. And as it rotates, it does not go through seasons. So imagine Mercury as just every day is the same. The sun rises at the same temperature and the sun, same time, sorry. The sun rises at the same time and the sun sets at the same time on Mercury. Whether it's June or July, Mercury's June or July, it is the same temperature, same season as it would be in its quote unquote winter. It does not go through its seasons. It stays the same. Venus also is straight up and down. However, it rotates backwards. So you could put an argument out there saying that Venus is actually tilted 180 degrees, directly upside down. So it's kind of standing on its head and rotating in the opposite direction of the Earth. But it does not rotate very fast. So that allows the sun to just bake and bake one side of Venus, and that heat spreads out around the whole planet because of its thick atmosphere. We then get to the Earth, and the Earth is tilted at 23.5 degrees. Then we see Mars over here, and I actually have a picture of, actually I don't right now, but in just a minute, I have a picture of Mars, and Mars is tilted. Mars is tilted just like the Earth. And here we go, we got Mars here. And Mars is tilted at kind of a 25-degree tilt, just a little bit more than the Earth. That allows Mars to go through seasons. And what scientists have noticed is on the north and south poles, you see this almost like a polar cap there. It's almost like snow and ice. There's the Northern Hemisphere while this picture was taken. And that is much bigger than the Southern Hemisphere. Scientists have noticed that as Mars goes through seasons, those polar caps grow and shrink. So Mars goes through seasons as well. After Mars is Jupiter, and Jupiter is pretty close to straight up and down. Jupiter, while it rotates straight up and down, it rotates really, really fast for its size. And that's what contributes to a lot of the swirling clouds going on in the atmosphere is Jupiter is rotating very, very fast, giving a lot of turbulence to those cloudy areas. After Jupiter is Saturn. Now Saturn is tilted on its axis. So if Saturn is tilted, does it go through seasons? Yes, it does. It goes through seasons where the top part, or what we would call the Northern Hemisphere, would be warmer as the direct rays are coming from the sun. Southern Hemisphere would be colder. So as it goes through its seasonal changes, scientists have noticed that it contributes to kind of weather events or storm formations. We know that on the top part of Saturn, there is kind of a hexagon on the north pole of Saturn. And when this was taken, they saw a hurricane actually swirling around on the north pole of Saturn. So Saturn is tilted like the Earth and goes through seasons. Now, lastly, I want to talk about this crazy planet. This one is Uranus. And let me bring up a different one of Uranus so that you can see those colors more clearly. But Uranus rotates on his side. Okay, so Uranus is completely tilted at 90 degrees so that he actually rotates on its side. So let me see if, don't have that one. So as it rotates on its side, imagine this, guys. Imagine that Uranus, as it goes around the sun never sets. Actually, it only sets one time during its year. Because it's tilted on its side, and let me try to bring up a better picture of Uranus here as I look for a different playlist here. Work with me. A little bit slow today. There we go. Here's one that has a little bit more distinct colors going on so that you can see that rotation. It almost looks like an eye staring at you, huh? Look at that. Now, as you can see, it rotates on its side. Now, imagine if you lived on this part of Uranus, this half of Uranus, and you were the sun shining on Uranus, the sun would just be doing circles in the sky until this part of Uranus faced away from the sun, And then it would be seeing the stars do circles. So as Uranus goes around or orbits around the sun, it goes through one day. So one day is about equal to a full year on Uranus. Bizarre planet to live, bizarre place. So just to wrap things up on seasons, the planets do go through seasons if they have a tilt to it. Okay? And some of them have a very extreme tilt. Now, going back to the GOES data set for the Earth and for the Western Hemisphere here, let's take a look at what has been happening weather-wise recently. So here is the United States at night. Here, as it color corrects, here is daytime. And we can see that smoke that we have been talking about in several of our previous Weather Wednesday episodes. We were talking about the fires going on in the west. And as I back it up here, you can see a lot of smoke in the west there. But thankfully, finally, the west has experienced a low pressure system which has brought clouds and rain to the west, particularly Washington and Oregon, which has really kind of doused those fires, thankfully, on the west coast. And so not as much smoke. You can see the effect there. Not as much smoke going up in the air because that rain has helped to extinguish a lot of that. And as we progress, we still, unfortunately, have a lot of fires going on in California. They're waiting for this low-pressure system to slide down and hopefully slide south enough to bring moisture. And so here is that low-pressure system. You can see that nice comma right there. That low-pressure system, as it moves onshore, really hoping that brings some moisture to California as well. Now, speaking of moisture, Texas and Louisiana is getting too much of it. Right now, Tropical Storm Beta, guys, we have run out of names for these storms in the Atlantic Ocean. There have been so many that we have run out of names. So now they're just using the Greek alphabet, alpha, beta, gamma, and so on. So now we are on Beta as it moves onshore. This thing is moving very slowly across the Texas shoreline and dropping a lot of moisture in the south. That is going to continue because of its slow motion, but eventually it will lose energy probably by Friday. But in the meantime, it's causing a lot of flooding in the Texas area. Lastly, we have this big system right here. This is the leftovers of Hurricane Teddy that was developing over the Atlantic Ocean. And as it is making its way up to New England, the Newfoundland area, up in Canada, it is going to bring some very strong winds and a lot of rainfall as it heads north there over the next couple days. So a very strong, very large system for the New England area. All right, so looks like we have some viewers saying, yes, they know personally that there is too much rain going on down in the Texas area. We hope that you guys dry out very quickly. That has been the story of this summer, is too much rain in some areas, too dry in other areas. There is just a lot of extremes that are going on. What is causing this? Well, scientists are still trying to study and figure out why all this is happening. But what we do know is that as temperatures of the oceans and of the land increase, that allows more evaporation of water, and that more water in the air contributes to more precipitation. It's just cause and effect. Speaking of cause and effects, and speaking of science, there is still some time to register for today's virtual home study program. We are going to be online today talking about why should we study space. So we hope that you guys can tune in to check on that. You guys can look at that on our website, discoverspace.org. Take a look at our screen. Our website is there that you guys can click on and register to watch our virtual home study program for today. Well, that is all for today's episode of Weather Wednesday. Thank you guys for following us. We look forward to seeing you guys next Wednesday as we see what the weather will bring us. And if you have any questions or want to reach out to us, we'd love hearing from you. Thanks for watching.